Geometry, shapes, and angles. So first, what is geometry? So it's a branch of mathematics that deals with the measurement, properties, and relationships of points, lines, angles, surfaces, and solids. So from Merriam-Webster.com. So what do you see in the picture? Okay. So in an ice cream, we can form a triangle. So triangle is found just in the bottom of the ice cream. So you can see there's a triangle forming in the bottom part of the ice cream. And we can also denote the triangle on the cream part of the ice cream. So an ice cream within a cone represents a shape of a triangle. So next picture, we have a box. A box represents a square, or sometimes it represents a rectangle. So rectangle and square are typically the same but on a different level. Okay. So another, we have a ball. So a ball is actually a round object. We represented it with a circle. So the previous picture that I've showed you representing the actual or the real the physical object is what we call a two-dimensional shapes. So a two-dimensional shape is a space enclosed by an outline. So as you can see, there's a space within the triangle. This is what we call the space. Okay, space. So they are enclosed by what we call the outline. So this is the outline. So we have the triangle, and we have the square, and also the circle. So are you familiar with the triangle, square, and circle? Okay, if you're a gamer, you're playing, they are very common in the PlayStation controller. We have the square, the triangle, and the circle. Although X is not what we call a shape, but it is what a considered part that makes a shape. So let's use a rectangle as our example. So a shape have dimensions. So the dimension of a shape is we have what we call the length. So the length is what we can see as the length, the longest side of the rectangle, of the shape. Okay, so we have two length of the rectangle. So it is the longer, or what we call the longest dimension of an object. And the shortest part is what we call the width. So the width is just the shortest part of the rectangle. So it is the extent of something from side to side. So a circle. So if you notice, a circle has no what we call side, or something that is horizontal, or something that is vertical, or a slanting straight line. So circle is made of curves. Okay. So we call the edge or the outer rim part of the circle as what we call the circumference. So it is the linear distance of a circle's edge, or what we call sometimes on Earth as the surface. Next, we have what we call the diameter. So the diameter is when you cut the circle in half. Perfect cut in half. So we have the diameter. It is defined as a chord that passes through the center of the circle. So any curve or any chord that pass through the center of the circle is called diameter. So we can have as much as an infinite number of diameter in a circle. So what if the radius? The radius is what we call the half of a diameter. So it is the distance from the center of the circle to its outer rim. It's just 1/2 of the diameter. Okay? So 1/2 of the diameter. So another part of our shapes is what we call the three-dimensional shapes. So it's a solid figure or or a tape that has three dimensions: the length, the width, and height or thickness. So we will use the box. So the bottom part, we have what we call the length, and on the other side, the width, and we have the height, or sometimes we call the thickness. Okay. Okay, to further understanding about shapes, what do you see in the picture? Okay, you see dots, bright dots in a darker picture. Okay, so the dots are what we call the stars, so that we see at night. So if we connect the dots together, so just imagine this is a straight line. Okay, then we form what we call a shape. So we have here a rectangular type shape. Okay, and we'll connect another dot and another dot. So that's what we call the Big Dipper. So okay. So our shape starts with what we call a point. So a point in geometry, it is a location. It has no size, no weight, no length, and no depth. So just simply a dot. But just to exaggerate it more, we made the dot much bigger. And to know that it is a point, not just a dirt in the paper, we will designate it with a letter. So either we would call it a point A, or point B, or point C, point until point Z. So which one you like. So now if we interconnect those points, we form a line. So it is defined as a line of points that extends infinitely in two directions. It has one dimension, so what we call the length. Points that are on the same line are called collinear points. So we have here a line. As you can see, there is an arrow going to the left and an arrow going to the right. It indicates that it extends infinitely in the left and infinitely to the right. So any points in the line is what we call collinear points. So the point C and point D is what we call a collinear line because it is found in a line A and B. So line A and B is written as A and B with an arrow, with a line and an arrow above. And we read that as line A and B, or line A, B. Next is what we call the line segment. So line segment, it has two endpoints. It contains these endpoints and all the points of the line between them. Now you can measure the length of a segment but not of a line, because a line is, as we define it, is infinitely moving to the left and moving to the right. So when we say line segment, it is measurable. So it has two endpoints. So we can now measure the line using a ruler. So we point out that the point on the left is point A, and the point in the right is point B, or simply A and B. So we write a line segment as AB with a bar above. So we read that as the line segment AB. Next is array. So array is a part of a line that has one endpoint and goes infinitely in only one direction. You cannot measure the length of array. So we use ray as when you are using a flashlight, there is always a starting point. So from the light bulb of the flashlight going infinitely to certain direction. So we have point B and point A. So point A is just symbolized as an arrow, and point B is signified as a dot. So it is written with letters with an arrow pointing in one direction. And we read that as ray B A. So plane. So plane extends infinitely in two dimensions. It has no thickness, and an example of plane is what we call a coordinate plane. A plane is named by 3 points in the plane that are not on the same line. So we have, for example, we have this rectangular shape and we have 3 dots. We called it point A, point B, and point C. And we signify those point A, point B, and point C, or more than points, as plane A, B, C, because they lie on the same plane. But if there's another rectangle and then with the letter of it, they are not on the same plane. So we will only write it as plane ABC if they lie on the same plane. Okay. So what do you see in the picture? Okay. This is a very common picture. You can see that at the intersection point in the road. So in geometry, we are also using that intersection and what we call it as an intersecting lines. So intersecting lines is a pair of lines, line segments or rays are intersecting if they have a common point. This common point is their point of intersection, and we call that an intersecting line. So we have here a line and a point in the middle. Okay. So if a line passes through another line, so the intersection, we call that line already an intersecting line. Now we have this picture. Okay, as you can see, there is a line here that extends infinitely going up, and another line here on the right side most part is moving up infinitely, but they do not meet at the end. Okay, so this picture is a very common picture. It's what we call the railroad. Okay, so the lines is called a parallel lines. So it is a lines or one or two or more, it's two or more lines that never intersect, so they never meet. So it's like you have a crush and you cannot talk to your crush, you cannot be with your crush. It's like you're both in a parallel line. Okay, next. So the next line is what we call the perpendicular lines. So its perpendicular lines are two distinct lines intersecting each other at 90 degrees. So what is 90 degrees? We can say that a 90 degrees is a perfect line. Okay, it forms here a perfect straight horizontal line and a perfect vertical line. So in the middle part, this is what we call the angle of intersection, or sometimes if it's written as if it's drawn as a square or rectangle, we can say that this line is designated as 90 degrees. Okay. So the 90 degrees form of the perpendicular line is what we call the angle. So angle can be defined as a figure formed by two rays meeting at a common endpoint. So we have a two rays, okay, meeting at a common endpoint. So the first ray is ray OA and ray OB. So OA is what we call the arm, and OB is also what we call the arm. So the two rays are considered as an arm, and the common endpoint is what we call the vertex. And the figure formed in between the two rays is what we call the angle. So there is an arc drawn between the two rays, and that's what we call the angle. So an angle is represented by the symbol. So we will be using this symbol to designate that what the figure we are talking is an angle. Okay, so we read that as an angle of AOB. So this symbol is always denoted as the term we use, angle. Okay. So how do we measure an angle? So we use a special tool. It's what we call the protractor. Okay, the protractor is for us to know the angle of a figure. So we can denote that as we will be starting a figure For example, we will be drawing a circle in between. So we will be starting from this point. So this is the common endpoint of a two angle. From this point, so this is as read as 0. So if you are measuring an object or a 90 degrees object, as you can see, you form a perfect line. Okay, you can already draw a square. So for example, there's here an object of a square. So the angle you read of the two rays formed by the two line form of the square or a rectangle is always designated as a 90 degrees. So in a triangle, if you're measuring a triangle, we will have a different angle, because a triangle is not always, for example, not always in a 30 degrees measurement. Okay, so a triangle can be either 30, can be 40, 60, 70 until 90. So one angle of a triangle can be either 90 or up to 10 degrees or much lower than 10 degrees. So what if the object we are measuring is already below a protractor? Okay, so we will be drawing here, for example, we have this type of a pie. We have your pie until here, so we are measuring the angle of our pie or pizza, that's the missing pieces of the pizza, so we want to know the angle of the pizza. So you will be needing another set of protractor, okay, so that we would be knowing the angle that is moved around there. So we would be starting here as 0, going up to 90 until going to 180. So from 180 we will add again plus 1 until we reach here. So we will plus 90. So 180 plus 90 until to going to 0 again. That's what we call 360 degrees. So a complete rotation, or the angle of the circle, is always 360 degrees. Next. So we have a types of angles. So not only a 90 degrees angle, we have also what we call the acute angle, which angle has a less than 90 degrees. So it's not only 45 degrees we are measuring for an acute angle. Acute angle can also be 30 degrees. It can be 10 degrees for as long as it is less than 90. A right angle is having an angle exactly 90 degrees. So as you can see, we can draw here the figure of a square instead of using an arc. So if you see a line with a square form in between the two rays or the two lines, it's always considered as a 90 degrees. And an obtuse angle is also the same as what we call the acute angle. The angle measurement should be in between 90 and 80 degrees. So it can be 145 for as long as it does not exceed 180 degrees and does not fall below 90 degrees. So it must be in between 90 degrees and 180 degrees. So that's what we call an obtuse angle. So a straight angle is an angle that is exactly 180 degrees. So a straight line has always an angle of 180 degrees. So a reflex angle, it is an angle in between 180 degrees and 360 degrees. So it can be more than, it can be 290 degrees for as long as it does not exceed 360 degrees. If it exceeds 360 degrees, that's what we already call an acute angle. So if it exceeds 360 degrees and it will fall beyond 180 degrees, it's either a straight angle or an obtuse angle. Okay, so a full angle is what we call is exactly 360 degrees. It's a full angle. So um, full rotation of the line. Okay, and that's all.